Okay, so what do I have going on here? I have this little meter here on the AC mains range. This is connected to the two inputs to the primary side of the mains transformer. So this will be reading what is coming from the dim bulb going to the unit. I've got this is a UU6 rectifier. I don't know, obviously it came with it, don't know whether it works, whatever. I've just found a PDF for it online. The two anode pins for, obviously it's a 2 diode device, so you get full wave rectification every other half cycle. So I've set up on the 10 times probes, and I haven't used the Finercy yet. I've had a quick look at the its signal generation and checked that the waveforms are generating, the actual leads are reading correctly. I've got the two earth probes from each lead connected to the same chassis, so they've got the same grounding point. You have to do that on the Finercy. I read the manual before I opened it, and unlike all other oscilloscopes that have the commons joined, they're not. They're insulated on this unit so that it can be floating, I guess. So this has got absolutely no connection to the mains at all, except through the earth, but only to each channel. So it will be referenced, any measurements will be referenced to the chassis, which is the only way it gets the earth back through the cable. But as far as the actual oscilloscope goes, there is no mains reference, because obviously it's not a mains unit. It's fed from the USB cable through the laptop. And I don't know if my laptop has a mains connection through its power supply, but anyway, that's by the by. But just so you know that this Finercy, unlike other oscilloscopes, it's not connected. The earths aren't actually linked here. So to get the same reference points on each probe, you need to have the two earth clips joined together so they've got the same reference. And obviously in this case they're both attached to the chassis, which is obviously ground in this case anyway. So at this point, without the rest of the valves in, there will be some DC getting onto the rest of the circuitry through this mains rectifier. Now this makes it kind of dangerous to handle this after, so disregards of all the other potential problems with this complete mess of a radio, which is why I'm doing this, just pure sort of curiosity really. But I'm going to have to be really careful in handling this afterwards. I'm only going to be going up to the first bulb voltage, which I will be reading, so I'll know how much AC is going to be put through to this unit at each stage, and hopefully we'll actually see what bulb gives enough power to this unit to actually start, if everything else is even okay, which I have no idea whether it will be. I mean, stuff could be short, who knows. I don't even know if this rectifier diode valve works, so there's loads of possibilities here. Right, so I'm going to power on now and see what happens, and whether I can get any readings on the... Right, so there we had a bit of power. You saw the flash of the bulb, and let's do an auto ranging on that and see if there's anything being read. Well, that's weird and interesting. Got two very different values there, and they're both set on ×10 obviously. So let's just auto arrange that again and see if it can make any sense of it. That seems to be a really strange value, but it looks like there's power being drawn to the rectifier somehow, I'm guessing, because we're actually pulling 14 watts of power, which I didn't expect at all. And I was certainly hoping... Well, that's really weird. I mean, I don't know enough about this scope at the moment. I'd have thought the auto ranging would have given... Right, and it's also, we've got a full... That's not good. We've got a full 180 volts AC being fed to this unit across the mains primary, so that's well into the power band, feeding nearly full mains to this unit, so I don't want to touch this for a while. after this. So, and it looks like at that voltage it's actually brought the rectifier tube well into emission, so I really didn't expect that at all. So I'd say this is actually working as a rectifier diode. It's in balance between the two sides by the look of it, unless I'm on different ranges, because I'm not overly familiar just yet with the... So let's bring these down. Let's bring that down. That doesn't want to come down. And the auto ranging isn't balancing those out. Just check that they're actually... So weird readings, but anyway, that looks, despite the difference in heights of the so I can't get those to be equal no matter what I do. But of course it is a brand new Furnace unit, and this is its first testing, so it's been thrown in at the deep end, that's for sure. Let's just stop the run and then try auto again. So without knowing exactly what's going on with these readings until I look at the scale a little bit better, but we've certainly got, so you can see 50 Hertz signal, and we've got nearly 190 volts AC just on this 25 watt bulb. So that's not what I expected at all, that it would feed that much power straight through to the unit. So kind of interesting. Right, I'm going to leave it there for a minute and have a think about what's going on. So unfortunately, without being able to look at the circuit diagram for this unit either, I'm a bit in the dark. So, but I'm going to switch this off now, and I won't be touching the underside of it, that's for sure, because I have no idea what capacitors may still be working enough to store charge, or what's going on with it. So there's no DC voltage being stored. These capacitors are literally just passing the AC. They're not actually storing any DC charge at all. And what I've done is I've connected this meter on the 200 volt DC range, and probing about any of the actual valve points of the empty valve sockets, the most I can find on any particular pin is 4.9 volts DC. So again, obviously I don't know what valves went where either, because I didn't take a photo. But just looking at the specs of one of the other valves, it's got a maximum anode voltage of 250 volts. So in principle, this unit should have nowhere above 250 volts on its DC rail anyway. But as you can see, no matter what, apart from the odd pin on any one of these that I probe with on the DC range, I don't get any more than 4.9 volts DC. So obviously there's no storage in the caps that are then generating the rectified DC to actually put a DC value anywhere on any of the valve pins, which at least if the rectification was happening properly, there would be higher voltage rectification going on. But because we can still see this mismatch between the two sides of the rectifier diode, then obviously, as you'd expect, you know, this unit, I mean, I'm amazed it's actually functioning the way it is, to be honest, with the state that it was in. So it just goes to show, you know, you just never know. I mean, if this thing was actually really, you know, if I wanted to spend the time and effort on it and actually take it apart and really clean it up and then recap it, you know, but I say it's just not worth it, you know, spending money on the caps. But it's certainly been an interesting exercise for, you know, a unit like this, so old and in such a horrendous state, can actually still function to some degree or another. So I'll have a think about what I want to do. What I might do the next go I'll step up through the bulbs and just see what's the maximum voltage I can actually get to feed to this unit, to the 240, and see what happens just with the rectifier in. And obviously all I'd expect is that possibly slightly these go up, you know, slightly higher peak values. even though they're not functioning correctly, and hope that, you know, because obviously these capacitors definitely aren't going to reform. There's no DC rectification going on here at all. So, you know, these would have to be changed at least. And I do have two, so I could, in principle, put a couple of 400 volt caps in replacement to replace these two, and actually then see again, but it's getting on kind of late. So I'll have a think about what I want to do.